structure. We are together. Side of the implementation. Fire hazard. Hello everyone. Today we're going to install a solar system in our home. Throughout this video, I'm going to go step by step of installing this entire system. So when it comes to solar system, there are three main categories: off-grid, on-grid, and hybrid. So today we're going to install a hybrid solar solution, but it operates as a first few quarters it will operate as a off-grid solution. So when a hybrid solution comes, there are three main parts. One is the panels, other one is the battery, then the inverter. So in here for the solar panels or PV arrays, I have a Trina 620 bifacial panels. I have 12 of them, which generate around like 7 kilowatt or something like that. So for the battery, I have a Goodby 14.3 kilowatt lithium iron phosphate battery. For the inverter, I have single phase 6 kilowatt inverter, which has 2 MPPT strings, and it's a hybrid inverter. So let's dive into the battery first. So for the battery, yeah, this is the battery. Yeah, this has 14.3 kilowatt hours of energy can be stored here, and externally we have the this is the top cover, I think. Yeah, it's the top cover which it's cover the terminals of the battery. Then we have a communication wire which communicate the battery status to the inverter, and we got some lugs for the battery cables and quick carriers, I think, and the mounting brackets, one the N terminal for comport, and screws, four plugs, like that, and a grounding cable and 2 battery wires. This will goes one side to the battery and otherwise to the other into the inverter. So yeah, that's what we receive with the battery. Let's go to the inverter. We have a mounting bracket and the same kind of communication cat cable for the connectivity between the battery, and this is a temperature sensor for, I think, lead acid batteries. Then we have the CD, which this is the part which read the export and import to the your home and from the inverter to the grid. And under this bag we have roll plugs and screws, which helps us to mount the entire inverter. Then communication dongle, a few MP4 connectors, then some lugs and two for those connectors, and some special kind of ferrules. These are a bit long than what we have in a typical stove, and yeah, a few other size of ferrules, screwdriver and connector for communication ports, which enable us to connect these cables to the inverter. Some screws and a plug. Yeah, that's it. And under this cover we have the inverter. So this would be 6 kilowatt hybrid inverter, single phase. This is the ES Unique series one. So this have a giant huge heat sinks. It's fully sealed type. Yeah. So under the giant we have these connectors. This is the one which connect to the battery and which connect those sensors, CTs, I think. Then this is the load and the grid and the generator. So with this model, it supports external generator as well, which is pretty awesome. And yeah, and 2 MPT strings. So this connected to one PV array and this connected to another PV array. So yeah, that's it for all devices. Okay, so let's start with the installation phase 1, which we're going to install these solar panels in the roof. So when it comes to the installation of the solar panels, mounting structure and the location that we are installing solar plays a crucial role. So for example, this entire area was designed to install solar systems. I designed it when I built this entire home. So this roof is tilted around like 10 degrees to maximize the solar gain, solar energy gain, and as well as leaving enough tilt to wash out the solar panels with the rain. So also the direction plays another crucial role. So I'm living in Sri Lanka, which is a country near equator. So in my country, the best solar installation direction is from south to north. So and it should be south faced. So this roof is designed in a way that it lies around south and north, and it's south faced. So this is the roof that I told you earlier. So as you can see, the entire roof is colored in white. So there is a reason for that. So I use a roof paint to cover this entire roof area using white, because in my installation I'm going to use bifacial solar panels. So it generate from the top side as well as the bottom side. So the white roof helps to give a little bit of extra power gain to the solar panel due to its reflexivity. So you can see beautiful sky there. And if I compare with this red kind of maroon kind of roof, you can see this is a clear difference. This has a very bright reflections with the roof. So yeah. So I'm at the roof now. Let's start the installation of the mounting structure. I divided this entire roof into 2 parts. The reason is that for evening half I don't get any shadows or obstacles which gonna make shadows on the solar panels. But for morning half, due to this tree, I'm getting a bit of shadow in this area of the first area of the roof. So due to that, I break this entire roof into 2 parts, which goes to one MPTT string and other one to other MPTT string. this helps to kind of maximize the energy gain during the morning half as well as evening half, because one MBT is individual generating the solar energy from this part of the room. So uh, the orientation of the solar panels will be kind of landscape and kind of following a row type. So the plan is to install 3 rows uh, in a solar panels in a horizontal manner. So one will be in a like this. This is a one row. Then other one will be like this. It's another row, and the final row will be like this. So for each row there will be 4 panels, and there we have 12 panels, which gonna be 3 rows. So, and there will be a bit of space between the each of the rows to maximize the energy gain from the back side of the solar panels. So with me to install these solar mount into the roof, I have a few items. First is these solar rails, which we call. These are very common in all kind of solar installation. This is the rail that solar panels will be stayed on, and this screw have a kind of clamping mechanism to hold the solar panels, and this screw will mount this entire rail to the roof. So it's pretty bright here. I can't even my eyes open. So to mount these solar rails into the roof, we have a few things. First, we have these. These are called asbestos base, which is this curly asbestos sheet, and this goes top of this and help us to get a nice little flat surface top of it. Then we have these are called serrated angle clamps. So I have a extended version of it, and the typical one a bit shorter, which reduce the airflow to the solar panels, underneath the solar panels, and reduce the light that we gain from the back of the solar panels. So these serrated angle clamps goes like this, and the railings, this groove of the railing goes with that, this clamp. So when we are installing these asbestos base and this clamp, the thing is like underneath this asbestos sheet there is an entire wooden structure. So first we need to drill a pilot hole using a drill, and then put this tape. These are called no-leak tapes in Sri Lanka. This is very gooey material, which help to reduce the water leakage into the wooden structure. I would say this is the entire kind of waterproof. So it goes first, then the asbestos base goes second, then the serrated clamps, and finally this screw. This screw also a bit special. It has a washer that has also kind of waterproof rubbery material top of the washer. So this screw is kind of self-tapping. So after we do pilot hole, the direct underneath we have the wooden structure, and using impact driver like this, we can directly drive this screw into the wooden structure. So with the screw, I am putting a little bit of silicon glue, so it will further improve the waterproofness of this installation. Yeah, I will get back to you once I install all these kind of these mounting mechanisms, and lay around the after complete the layer round of solar rails. So it's evening, and we have completed installing the rails and the mounting system. So if you look at the single joint, you can see first that no leak tapes goes. Then you can see there's a silicon layer underneath. After that, then the asbestos base, then another silicon layer, then the washer. Yeah, so that's all about the installing these solar arrays to the roof. So yeah, next another important thing is after we done this, we need to ground the entire system to the ground the entire system. So the reason is that lightning and mainly lightning. So to that we have these special kind of clamp. So these are called grounding clamps, and you can see this has a groove which we can put the earth or grounding wires, and it has this nice little thin metal sheet which has these kind of spikes. So the main reason is that, so even though these feels like aluminium railings, these have a thinner coat of some kind of non-conductive thinner coat. So the purpose of the spike is, and the entire purpose of the sheet is to penetrate that thin coating and bond with the real aluminium and make it groundable. So yeah, so in here you can see I put 10 gauge grounding wire into that earth clamp, and you can see how this gonna be connected, and I need to connect each of every rails to single ground and connect it to the house ground. So you can put a silicon in here to make it less corrosive, otherwise it gonna be corroded in few years. So to clear that rubbery coating on the wire, you can't use these kind of typical wire strippers. This won't do the job. So instead you can use a knife and cut a section of a wire and clean it up and connect it. Yeah, that's it. So now I'm connecting these grounding cables to each of the rail, and yeah, so we have completed the installation of the mounting structure as well as the process of grounding it. So now we are in the third floor. So now the next step is to lay around the PV wires. So we have two positives and two negatives for each PV array. So this is the those PV wires need to be carried out to the inverter area. So when I designed this home, this is the place that I plan to install this inverter. So we have the laser level here. So I calculate some spaces with the inverter sizes and the distribution board sizes. So and this is the place that I need those PV wires. So yeah, so for in my installation, I'm just gonna directly drew a hole, 3 holes to the ceiling to the roof, which one is for 2 positives, one is for 2 negatives, and other one is for the earth grounding. Yeah, but in my opinion, I will not recommend it to do it, because drilling a hole in your roof is not that good. I will recommend an approach like you can get those PV. The thing is, those PV wires will be encapsulated with a PVC tube, and I will recommend you to lay around those PVC tubes top of the roof and get like here and connected it to the any kind of ceiling or something like that, then get to the inert location. But in my case, I just gonna drew a few holes through the ceiling to the roof, and cover those PVC tubes and the space between the roof with some roof sealant, as well as cover the entire hole with the roofing sheet, so it won't get exposed to the rain and it will be kind of waterproof. Yeah, we'll get back to you. So using this hole saw, I drew 3 holes, one for positive, one for negative, and one for earth. Then after that, I using a normal drill bit, I drilled a pilot hole into the roofing sheet, so I can get the location of it from the roof. So after drilling the pilot hole, I using a step bit, I enhance the size of it. So after that, I lay down all the PV wires, negative and positives. Then cover it up with the PVC pipes, as you can see. So when it comes to installing the solar panels, we need to consider another thing. So since we are dealing with DC voltage, the quality of the wire make a huge impact on the generation. So you need to consider what wire gauge you should use in your according to your PV array size and voltages and amperage. And in my case, I use 6mm. This wire is from German, called KB Berlin. So using those wires, I complete the installation. After we lay down the wires, we have to ensure that we get connected it with using these MC4 connectors. These are pretty common in solar installation, and we have female and male connectors. This male, and installing it to the wire is very easy. Connected into the wire is very easy. So you can just crimp down these metal parts and set up the connectors. So all the PV wiring is completed. Now we are moving to sealing this entire this section using a roof sealer. So yeah, this is the roof sealer that I'm gonna use. This is called Sin Roof, and to add some strongness, I use these pre-cutted fiber meshes. So yeah, the sealing part is very straightforward. You can use a simple brush and these fiber meshes to seal out the holes. First I am applying a gentle layer of roof sealant. Then for the holes, I'm going to apply that fiber meshes. Yeah, that's it. So that is the roof sealant part. On top of this junction, I'm gonna revert this sheet. This will act as a rain cover to this entire area, which help us to make it waterproof more. So yeah, apart from that, you can see I lay down the earth wire as well, the ground wire, and connected it to this rail, and which connect the railing system to this ground. And I additionally put another wire. This gonna be connected to the solar panel system, which help to ground in the entire solar panels to the ground as well. So yeah, so this is the final look of the mounting structure and the wiring. So as you can see, I have applied the roof sealant into each of the mounting bases as well. So this make the mounting bases and the bolts and the stuff a bit less corrosive, as well as the entire joints are more water resistance. And this is the this is the sheet that I showed you earlier, and we applied the rivets and mount the sheet top of that junction area, and I covered that as well using the roof sealant, because it's going to be white and improve the solar generation. So yeah, everything now is done. Only thing remaining is for the installation of the solar panel is to mount the solar panels and connect it to the wires. So one thing that I missed earlier is that when you selecting the wires, you need to select a wire which are double insulated, which provide more kind of safe to use. So yeah, that's all about it. So now time to start installing these solar panels. Before we move into that, I need to show you some items that we need to install these solar panels. So in a typical installation, these solar panels are put at top of the railings, and using these end clamps and mid clamps, we are fitted it to the solar rails. So these are called end clamps, which goes like this in the solar panel. The railings will be below that. Then these are called mid clamps, which goes like this, and in this side there will be another solar panels. So in my case, I don't need middle clamps, since I am installing these in a row, 3 rows, and since I have a little bit of gap between them to as a service path, as well as to enhance the light, so I don't need these middle clamps. You try 2 end clamps and mount a single row, then another 2 end clamps for the second row. So when you connect the wires, you need to do the wire management. So for that, you can't use the typical zip tie that you use daily. You need a special kind of these stainless steel zip ties. These are UV protected, and nothing, it's not gonna break even 20 years. So apart from that, we have these clips. These are called rain clips, as I remember. So what this does is, when the rainwater is top of the panel, it drain it out. So there will be no rainwater under in the edges of the panel. So when it comes to the grounding these solar panels, there are 2 common ways that been used. So one is using these earth plates, other one is using typical copper wires. So how this earth plate work is, when you are fixing the mid clamp, you put like this, and the rail will be goes here, and this earth plate goes like this. So what happen is when you tight the screws, this will penetrate the panel as well as the rail. As I told you earlier, like the solar rails, there is another non-conductive coating on this as well. So if I check using my multimeter, let me go to the continuity mode. So now the meeting in continuity mode. If there is a electrical flow, it will beep. So if I touch two places of the panel, nothing. So if I touch some inner place of the solar panel, and there's another inner place, you can see the continuity is there. So there's a code that prevent the electricity going through the solar panel in the solar panel. So the second way of doing that is doing the grounding is using the typical copper cables. So in a normal condition, solar panel manufacturer put these grounding poles that you can install these kind of copper wires. So in my country, we don't have this mechanism to grounding. So in most of the countries, there is a pre-built this kind of cable that has these two lugs, and everything is pre-built, and you just need to buy this. But in my case, I don't have that thing. In Sri Lanka, we don't use this topology to ground the panels. So I made this cable myself. So what I did was, there is a lug like this, and I bought 6mm earth wire and put this lug top of it, and using the lugging tool, I tied this. Then I put a small heat shrink over here, and finally the wire boot goes like this. So I did it to the both ends of the wire. And how I'm gonna fix this to this hole is using these screws. These are stainless steel screws. These are nut and bolts actually. So I have these bolts and washers, and this special type of washers. I will tell you the reason later. So how this gonna fix is, as I told you earlier, there is a kind of a small thinner a coating top of the solar panel aluminium body, which prevent the electricity. So this crush washer is going to penetrate that thinner coat. I need to take this user like this, and insert the nut and crush washer, and then the here, then using impact driver, I'm gonna try this. Yes, so I'm aligning this So now what will happen is this that special washer gonna crush the thinner coat and bond the uh, copper wire to the body. So if I check the end of this earth terminal with the body again, you can see the connectivity completed. So in my installation, I'm going to use both of the grounding mechanism to improve the grounding. We have successfully laid down the first 4 solar panels, and apart from the metal zip tied, these are called wire clips, which also can be used to do the wire management. Also, we have successfully mounted the all solar panels and complete the wiring. So this space is it's called a service path, and there's another one goes here. In my solar installation, this serve 2 things. One is to maintain the solar panel, clean it up and do the maintenance, and the another one is to get the more light into the backside of solar, so we will get more kind of generation. These kind of edge spaces will increase the solar generation when it comes to the bifacial solar panels. So if I go here, you can see there is a PVC tubes go around. The reason is that the one PV, these 3 panels and these 3 panels and these 3 panels, sorry, these 2 panels and these 2 panels and these 2 panels are following a single PV, work as single PV array, and these two and these 2 will following another PV array. The PV seriousing work like a snake in my wiring. So the positive start here, connected to this panel, then to this panel, then to this panel, then it goes to this area, this panel, then this panel, and to the my inverter. So I have installed these PVC tubings over there and here. So this is the where the wires are crossing to this side of the panel, to this side of the panel. So yeah, likewise we have those PVC tubing there and here, which goes panel row to row. Yeah, that's all about it. This is the complete installation of the PV array. So this is the completion of the phase 1. So let's start the phase 2 of the installation, which is installing the hybrid inverter. So in here you can see we have 2 positive PV array wires, which one is connected to one array and the other one is to another. So this is the 2 negatives and the grounding cable which connected the entire solar panels and the mounting structure. And in this side I have 2 wires which goes to the entire my house load, and 2 wires which has the grid power. Then the earth wire which goes to the directly to the my grounding mechanism earth. So yeah, as I told you earlier, I'm gonna use this hybrid inverter for, I don't know, maybe a few years in a complete off-grid setup. So the first thing I'm gonna do is mark the location of the distribution boxes, combiner boxes, and the insulation bars and combiner bars and the inverter, so I can drill holes and install these combiner boxes Yeah. So for the AC side, I have planned two combined. One will be for the uh, grid side. There will be SPD and voltage regulator and backfeed protection and AC isolator. Then AC isolator and backfeed protection will be in another separate compartment. So, but it goes to the grid side, and the for load side, I'm going to install a voltage regulator and SPD. And for the DC side, there will be two SPDs, two fuses, yeah, those are stuff, and DC isolator, which is very important. So all of these wires are de-energized, completely safe to work. That's one of the important things that you need to ensure, because these are very dangerous to work with. Yeah, I'm gonna measure some distance and start the marking the where which place the combined boxes goes, and the insulation and bus bars and stuff like that. This will be my DC combined box that goes here. This is gonna be my AC combined boxes. Which one goes like this? And the other one goes like this. There will be a DC isolator. The second AC combined box. Like this. So if you can't see, this is how the combiner boxes will be look like. So this is kind of water resistance. This goes like this. These are for another thing. In Sri Lanka, according to the electrical standards and general sense, we have to use double insulated cables for everything, for AC side as well as DC side. So these are double insulated wires, and these also double insulated wire. And I am adding these insulation boxes as extra safety. So, and I will be covering all the exposed wires using a flexible hose, which also kind of provided extra safety for the wires. This is the base plate of the mounting plate of the inverter. So I marked the locations, and now I'm gonna do a hole into the wall. So these are the screws provided by Goodby. So these are I think 8. So I use 8mm diameter drill bit and a rotary hammer to drill the wall, so I can set the mounting plate. Now I'm going to install the wall plugs. One thing that you need to remember is when you are drilling the holes, you need to be sure that you at least drill 80 millimeter. Yeah, 80 millimeter hole into the board. So yeah. Using a impact driver, I'm gonna drive these screws. So top of the I complete the installation of that mounting bracket and install the inverter. So it looks like this. Easy to touch, easy to operate, and kind of kid safe. Now I'm gonna cut this insulation box bar with the size of the board. So this serves as a main kind of power bus to the DC area as well as the AC area and the inverter and the batteries. So yeah, to cut this, I will use this circular saw so I can have a clean cuts. Yeah. I drew the pilot holes in the insulation box bar. Then these are those pilot holes. So now what I'm going to do is I'm gonna do the real holes into the wall and mount the the insulation box bar using these wall plugs and screws. One thing to note that is I drew the pilot hole using 4 or 5 millimeter drill bit, so it will be just enough to go through the 6 millimeter screws, and I am gonna use 6 millimeter drill bit with the hammer mode to drill these holes and install these wall plugs and the screws with the insulation box bar. Main bus bar is finished. Now I'm gonna cut these insulation boxes as well, so these can be fitted. The thing is, this it will be fitted in a vertical manner like this, and there will be a DC combiner box in the middle. So I'm gonna cut these the same way that I cut the main bar and mount these to this hose bar. So there will be 2 going here and 3 going here. Yeah. So as you can see, now I have mounted the top part of the enclosure, then the DC combination box, the bottom part, and the previously mounted this part. Then I drew the holes through using each of hole saw. So we can put these wires from here to here to here. Yeah. Now we move to this side and mount these 2 combiner boxes and then closures. So we complete the AC combiner boxes and the enclosure around it. Now I'm going to install these 2. One is a AC isolator. So this is a brand this has a enclosure box which can be mounted, and this is the core component. So using this switch we can cut off the export or import from the grid. Basically we can isolate the grid from our system. So this is the second thing. This is called a back feed protector. So what this does is when the power goes out or intentionally power cut off, or when there is maintenance from the utility provider, this avoids the power getting into the grid through our system if there is a power cut. So basically it's a magnetic relay. When the power is on, it will be on, and the power is gone, it will be cut off. So there will be no kind of exporting from our system to grid. So I'm going to install these two in here and here, yeah, in the same manner. So now you can see we have successfully completed the installation of the isolator and the feedback protector. Now I'm gonna wire this DC combiner box. So for that I have two devices. One is this isolator, which is 4-string isolator. It's a DC isolator. So this will be act as most main isolator for the DC side. Then these are SPDs for each PV strings. So I have two SPDs. These are from a brand called Phoenix from Germany, and these are from Z-Benny, then Z-Benny, whatever. So then and I have 4 fusers which also goes to the DC side. And apart from these devices, I'm going to use these ferrules to kind of connect the wires to these items. Yeah. So I'm in the middle of fixing the DC combiner box. One quick tip is that we have these kind of double ferrules. I'm not sure what it called, but double ferrules. So it will be easier if you use that to connect two wires, DC wires together. So another thing is you need to use a ferrule tightener to do this work, and you can easily connect two wires into a single point where you need such connections. So I have completed the wiring of the DC combiner box. This is how it gonna looks like. DC wires and the ground cable comes from here, goes to the isolator first. Then these wires are disconnected because I don't know about the polarity of the not the polarity, which cable belongs to which PV array. So once I figure out, I will connect it to the respective ports. Then the two PV array wires goes like this, two SPDs, then to the fusers, and go through here, and it comes like this, and to the place where we mount the inverter. So the next step is to connect these PV wires to the inverter. So to get the wire out of this enclosure box bar, I'm using these wire glands and as well as these flexible wire tubings. So it will provide more safety to the wire. So DC side is now complete. We have connected the MC4 connectors, and all wirings are connected with proper gear. So now we have to move to the AC side of the implementation. For the each combiner boxes, I'll be installing these Phoenix SPDs, two SPDs for two combiner boxes, and there will be another voltage regulator like this for each of the combiner boxes to make sure we are on the proper voltage level and make sure that inverter is not producing voltage to the grid as well as to our systems. So then there will be a MCB for each, which we can turn off the rate or the load from the combiners. So I have completed the AC side as well now. So this is how the current status of the distribution panels and the inverter and our system are. So I will go through a quick look. So if we go to the DC side, now all the wires are energized. So from the DC side we have positive and negative. It goes direct to the isolator, then it goes to the SPDs, then the fuses, then we have all the earth connections here, and then it goes like this into the inverter. These are the flexible hoses that we use, and these are the MC4 connectors. Then if I come to the AC side, so this is the load combiner box. So load is here, and our inverter supplies goes like this and boom to this. Then it just MCB, then SPD and a voltage regulator. Then for the AC grid inside, so it comes from here, goes down to this, and goes down to this, and it first goes to this isolator, AC isolator. Then it goes like this to the backfeed protector, and then it comes back here and goes to the MCB, then to the SPDs, then to the voltage regulator, and then to the inverter. So these are the output wires. So this is the grid in, and this is the loads. So line and neutral, and this is a single wire that has two wires, which is line and neutral. Then if I explain a bit further with this backfeed protection device, the thing is, in our electrical codes in Sri Lanka, we need to install this backfeed protection device separately as a independent component. So what I did was, since I can't find a backfeed protector device, I get a magnetic connector, and I will use as a backfeed protector. So if you are unfamiliar, magnetic connectors are used in motors, when we have powerful motors, to operate the motors and handle those large currents. These devices are normally used. But what this does is, it has a magnetic coil inside this area, and the two contactors are like this. So once the magnetic coil is energized, these contactors pull each other and make a connection. So in here, what I did was, I have line and neutral here, which is the input, and the line and neutral here, which is the output. So I connected the neutral to this connection box, and get an extra neutral, and here I connected this the lines. So these gonna be the breaking points. So what will happen is, when the power is on, these wires carry small electricity into the coil. So when that is energized, the magnetic connector works and link these line together, which allows them to act as a close switch. So once the power is out, the coil is de-energized and this will release and it will open. So in here I use these are called wire foots. So if you are exposing some upper parts in your installation, you can use these wire foots, so it will be a bit safe around those areas. So another thing that I need to mention is this is a 5.5 kilowatt connector. So this allows us to deliver 5.5 kilowatt through each channel. So this is a three-phase connector. So what I did was I wired two phases together, so it will be allowing more current to pass through this through the connector. So yeah, so this is about the back feed protection. Let's see how the entire system works. So now the AC side is also energized. So if I turn this isolator on in backfeed protective, you can hear noise, click sound actually. So now you can see the rail is that connection rail is below and connecting the connections. So if I switch it again and again, this is the switch off mode, and when I turn it on, it goes like this. So that's how the backfeed protection works, and then it current goes. Let's make it on, and the wires are energized now. Current are going through this to the distribution box. If I turn on the breaker, you can see it's 233 volt now from the grid to these wires. So now what is left is I need to carry those wires into here and install the flexible tubing and connect these power line into the inverter. So in the inverter you can see there's a backup mode, backup, and the generator in and the grid. So yeah, that's the load gonna connected to the backup mode, since I'm using this as a complete off-grid mode. Now I have contacted the flexible hoses and wire glands and the enclosure for the power port, and squeeze the ferrules, and now these are the my load wires, and these are the grid wires, and now the thing that left is to connect these up, and we have this moisture protecting rubber thing that we need to put it here. So I'm gonna add some silicone to this hole, so it will be no leaks from these flexible hosings. So then I can tie this out with the given tightener, the Allen key, and finish the AC side of the installation. Now everything is installed, the grid and the load connected to the inverter. I have complete the installation of these flexible hoses as well. So now we have complete the AC side, all equipment are installed, then the power is on, ready to be fetched into the inverter. Then DC side also completed. What is left is to install these communication related stuff. First one will be the communication dongle, which goes under here. It's a typical USB stick. So then we have the network wires for the communication wires for the battery, and the CT, current transformer. Current transformer will go something around here, and since I'm going to install the battery in the phase 3, I'm going to install the communication wire as well too, so I can set up it in this phase 3. Yeah, those communication ports are in here, but the noise is raining there. But I have installed the CD here. This is the grid 2. The thing is, since I'm running on completely off grid, so this is the place that I can install CD, where this is the grid where it comes from. Then I hooked up the BMS wire and the CT wire to the cable gland, which provided by the Goodby. Then where it goes is under the inverter. You can see the BMS port and the where we put the CT. Yeah, so now it's time to install the earth for the casing. So to do that, I'm gonna drill a hole in here and add a wire gland, flexible hose, and connect the earth. Yeah, the earth is connected, so we have connected the inverter body to the our earth system. So, and apart from the inverter related stuff, I connect the battery earth cable as well to our earth. So this is a connector that we can attach few wires into it. So yeah, now what I'm going to do is I'm gonna clean this up and attach the casings and finish these AC combined box and DC combined box and these items as well. So to the top of the each holes, I'm gonna leave this kind of foam with the silicone, so dust won't get into these boxes. So this is how the complete thing looks like when I install the covers. This is the phase 3 of the video, which we installed this battery. Yeah, so when it comes to the solar batteries, these are really heavy. So for example, this is 14.3 kilowatt hour battery, so this is around like 150 kilograms. So if you are installing in a second floor or third floor, so you might need assistance of a crane or a boom truck or something like that, so which can lift this stuff into the upper floors. So I'll recommend to install these things in the ground floor. One, it will be easy. Other one will be it's safe, because these are kind of fire hazard. So yeah, it's probably good to install these on the ground floor, so it will be easier to manage in a occurring of fire. So yeah, now we're gonna install this big boy into our system. So the previous phase I installed these two wires. One is for battery management, other one is for the battery management communication, and other one is for the ground. So now I have those two wires, and I need to get these wires out of from here. Yeah, from here. using a gland, then through a flexible hose I'm gonna mount it to here, and these are the wires it comes from. It's really heavy, so even wires are heavy. So these will be one side of these wires will be go to the inverter, and another one will be go to the battery. So I'm gonna, to add a more little bit of protection, I'm gonna cover these with also using flexible hoses, PVC hoses, and wire it up to the battery. So yeah, after that I think we're good to go. So turn on the inverter and try whether it's working. So I have installed the network and earth out to the battery, and as well as the main connection. So this is how it looks like now. So now using this top cover, will cover this area, the top of the battery. Then after finishing this box bar, this is how the end results of our installation looks like. So the project is I would say 99.9% completed. So battery is connected, inverter is powered on, and everything's working fine. So I have used this for about a day now. As you can see, it's producing the solar energy as well as charging the batteries. Then so when I say 99.9, the 0.1 remaining is to install these mechanisms. So one is the stickers, safety hazard stickers. Then I'm going to install this small CCTV camera to monitor this area. So it will give me a chance to see this from a remote location and see the status of it. Then whether it's gonna be, if there's a fire or something like that. So then the smoke alarm. So this is a 2-year supported smart alarm. So this will be connecting to my smart home systems. And the thing is, in my house I installed entire house is kind of a smart home which has many sirens. So if there are any fire in this area, I can get notified via those sirens. They're pretty loud. So to do the verification, I'm using this camera. So if there's any false positive, or just to watch the entire area. So then the another most important thing is fire extinguishing device. So I'm going to install here, the other side of this wall. So yeah, CCTV camera installed. Then all the burning stickers are installed. You can see we have few hazard stickers and info stickers, and each one is labeled. There is the shutdown procedure. Then the smoke sensor is installed. So and the fire extinguisher is here installed. Yeah, so this is the complete installation of the solar system. So in phase 1 we did the EV array installation. Then phase 2 we installed this inverter. Then phase 3 we installed these batteries and other related stuff. So that's about it. this is the completion of the my solar installation. So if I talk about the softwares, so to the inverter, we have two softwares. One is Solar Go, which do the configuration of the inverter, mainly specified for configuration, and for monitoring we use SEMS Plus by Goodby. So for the CCTV camera, it's a brand called EasyViz, which is a subsidiary of Hikvision, so we use that. And for the smoke sensor, it's 2-year protocol, so Smart Life app can do the configuring and monitoring. So apart from this installation, we need to consider about the main distribution box as well as the home groundings when we install a solar. So I will show you how my home groundings looks like now, and the way I did it in the top of part of the video, and then I will show you my distribution box looks like, how my distribution box looks like. So these are the grounding points of my house. So I have two grounding points. These are parallel earth, so main grounding cables comes from here to this, and these two are also connected. Sorry, the entire area is messed up here. So if I try to open one, I'm not sure whether I can do. Oh yeah. You can see how the grounding was done. So there's two wires just to make it better contact. So I have lugs with some heat tight, and this is a galvanized tube, and in here I have a 10 feet tube, sorry, 10 feet rod. It's copper. I'm trying this device I was able to open. So this is the main earth rod. So this and that is connected in a parallel way, so it will make resistance low. So this is the main distribution board of my house. So I have another one in the second floor, but this is the where we get the power and the all the breakers related to the first floor. So in here I have the grid and the solar in the inverter output. So, and I have a SPD, so this is connected to the directly to the grid power. So if there are any lightnings or surges, it will do the job. Then we have the grid power and the solar power, and here we have a ATS, automatic transmission switch. The reason is that let's assume if there is any outage in the inverter, so if there is any restart or offline inverter mode or something like that happens, what this device do is it will automatically change over to the grid. So if we doing this manually, let me turn off the solar, which is the source A. You can see instantly it switched to the grid. So now the entire home is operating on the normal grid power. So if I turn the back solar, you can see automatically move to the solar power. So after that, so in here we have the grid, in here we have the solar power. Then after that we have another AC MCB which power up the inverter. So this is the grid in of our inverter. So if I turn off from the first floor, it will cut off the grid power to the inverter. So in the second row I have some of our house breakers. So first we have a smart meter which connected to our smart home system and measure the power usage of the entire house. Then we have a AC MCB which act as the main MCB of the first floor. Then there is another MCB and a trip in the second floor. Then we have the trip or GFC breaker which break the current if there any leakage or grounding. So then we have set of breakers for the first floor. Then also here these breakers are also for the first floor. Then what I did in my DP is, you can see there is another GFC protector in here with another two breakers. So what this does is, let's say the thing is I want to kind of bypass the entire inverter to few power sockets. For example, I have instant water heater which consume around like 3500 watts, which is 3.5 kilowatts. If I turn on that instant heater in a situation where the house load also in a higher state, so it may restart or overload the inverter. So for that reason I have entirely separated power line which power those instant heaters and few high power outlets. So that's why I have another GFC protector and two breakers which is kind of entirely separated from the solar energy. So yeah, this is the overall look of the my main distribution board. In second floor I have a typical distribution board which have these MCBs, SPDs, GFCs and stuff like breakers